Welcome! In this video we will look at creating a web server with the PowerBasic Windows compiler. Our experience with accessing web pages removes us from the technicalities of what actually happens when we click on a URL link to access a web page. The communications link between our computer and the web server is designed to deliver our request to the server and receive the response back without us knowing what has actually taken place. Our browser is an application running on our local computer, which for a simple web page first asks for the web page file, the HTML file, from the web server. The web server delivers this file and considers its job done. The browser then scans through the received HTML file to see if there are any other additional files, in this case images, that need to be requested before the web page can be fully rendered on screen for the user. The web server delivers each of these files as they are requested in a separate transaction. The web server doesn't really need to know that the web page might contain 10 images. It's up to the browser to ask for them. So in this video we will be creating a simple web server to perform these functions. The web server we're going to create today is going to be a fairly simple web server. Its sole task in life will be accepting requests for files from the web server and returning the files to the browser. This will not have any fancy elements of JavaScript or PHP involved in it. Maybe they will do that in a later video. So, from the PowerBasic Windows compiler, what we want to do first is to create a form. And all we're going to do in this form is basically put a button on it. A very straightforward form. This form will have two functions. Its first function is to give the user a large button to click on when they wish to stop the web server, and its second function will be to provide the event handling for our web server. Right, there we go, a nice easy little button. So if we save that, and there's our code. Now for safety, we'll use the debug option for error handling. This ensures that since we're going to be using arrays inside this program, should we overstep the bounds of an array, the program won't crash, it will just generate an error and keep going. So what do we actually need in our program to get this to work? Well, first things first, let's go down to where the event handler is. The event handler here is going to end the dialog in the event that the button gets pushed. So if we compile and run that program now, it will deliver a button on the screen, which, should we click on the button, it stops the program running. So far so good. Now, since we're going to be doing a few functions within this that are going to be using parts of the system we've not touched before, we need to put a couple of includes in. Ideally in this one, we want to add in an include to pull in information about the Windows socket. Now PowerBasic does provide you with an include file which contains all the code that we'll need, which is ideal. So having got that in place, there are a few constants we want to put into the system. Now it's already generated two constants already for the dialog and for the button. What we're going to add are a few more constants to allow us to handle what's going to be happening inside the web server. Now I'll go through these one by one. we're setting a user constant up, a message constant, a page request constant, the port number the website will respond to, I'll come back to that in a moment, a delay for the monitoring of each of the threads, because we're going to be using thread handling, which we covered in a previous video, a maximum age in seconds of a thread before we automatically kill it off, a maximum number of threads that are actually running, 1,000 is more than enough for what we're actually doing in here, and a constant to allow us to mark a thread that we wish to tell the thread we want it to terminate, to self-terminate. The port number. Normally when you access a web page, the port number of 80 is assumed. You don't normally have to put a port number in when you're asking for a website. In this case, we're using port 8000, just in case on any of your machines that you happen to have a web server already running using port 80. Now, another thing we want to actually add to this is, since the web server will be running on your machine, one of the things it's probably best to do is to check to make sure that the program is not already running. Now, there's a couple ways we can actually do that. What we're going to do is we're going to add one of our libraries here. Now, I have a library I prepared earlier called PB Processes. Now we're going to include that one in. And I'll explain what the PB Processes actually does. There are a number of functions in here, and the one we're specifically after is this one here. This is a bit of pre-built code I created to, every time you call it, you pass it the name of the process you're interested in, and it checks how many of those processes are actually running on the computer at this point in time. Now, ideally there should only be one, the one that you're running. If there's any more than one, then it means there's another process of the same name already running on your computer, and that's not what we want. So, what we can do, just copy this line of code, and in the PB main, and we'll get rid of that at the end, that was debris from the build, and go to the PB main. What we're wanting here is the very first line of code, before it does anything, is to check how many processes are actually running. Now this uses a Windows API call, which is a library we've already included, to get the name of the application. And if the name of the application comes back from this function to say there is more than one running, then we want the program just to exit. This will stop two web servers running at the same time using the same port number. That's not a scenario you want to go to. So, having got that out of the way, let's just compile our program to make sure it compiles clean. No, it doesn't, because we didn't tell it to go to the libraries. Right, and now that we've put the path into the libraries correctly, it can run quite happily. So, first thing to do, if we go to our main PB function, what we want to do before we actually show the window, we're going to do a couple of things in here. Ideally, I want a text window. Now, in a console program, you can always throw information out to the console all the time. But since this is a Windows program, there is no console. So PowerBasic does provide you with a very useful text window. Now, what this does is it creates a text window on the screen. So this is an additional window in addition to the dialog we just put up. It titles it console output. It puts it in the position at the top left-hand corner of the screen. It's basically going to be 40 rows and 80 columns. Now we send this to a global constant, so we'll have to declare our global constant. And if we just try running this now, there is our console window. Now we can print information to this quite happily. So anything we put into here, just using a text print, and there we go. Now you'll find in all of our Windows programming, this particular text window approach can be very useful. It can be used to output debug information while you're actually developing a program. It doesn't have to be used at runtime. It's very useful from a debug point of view. So we've now got our window going. There's a couple other constants we'll want to create. So let's go back up to our declarations. There's a few more globals we want to create. Now these are globals that are going to be used within our program. Global for the TCP handle, the monitor thread handle, a couple of arrays to keep track of the ID numbers of the threads we're going to be creating, as we're going to be creating up to 1,000 of them. A double value for the start times of all the threads, and again this will match the number of entries in the ID thread array. A general file number and a handle for a dialog. Having got those set up, we'll want to redimension those arrays because we haven't given them a size yet. So one of the things we also set up earlier was a number of constants, and one was the max number of threads. So what we're going to do is we're going to redimension our arrays before our program gets going. We will set these up now. Now these are going to be from between 0 and the max number of threads, which happens to be 1,000. So these are two arrays, global arrays, which will have 1,000 elements in them. Now I also want to pick up a file handle I'm going to be using for TCP operations, using the free file command we used before, which generates a unique file handle. And now we're ready to actually go into the work of listening for incoming requests. So if we have a look inside our event handler for the dialog, this is the basic dialog event handler it's set up for you. There's a place for initialization, for activation, and for basically handling the pushing of the single button to close the application down. We're going to be concentrating at the moment inside the initialization routine. So we'll want a couple of local variables in here. So first of all, we'll set those up. One for an IP address and one for a socket number. Now, first thing we can do is we can use the text commands basically to clear out anything that's in the text window already. You'll find if you look in the help that the text object does have quite a few things you can actually do with it. Obviously it's not as good as a dialog window, but for just putting information out to the screen, even in colour, and you can actually wait for information on the keyboard if it's needed. For basic things it's enough. It'll do quite nicely. So what we're going to do here, we're going to print some information out to the text window using the prefix command, and each one of these lines will be prefaced with the text print command, just to say to use a web server you need to run a browser program and enter the URL location, or if you're running it as a local host, and then click the button in the dialog to close the web server. Now if we try running that now, what we'll get is that information goes out to the window. And this is what the user will see when the web server is set up. And we'll continue with this unless any requests come in for files, which will be printed out to here, and they can press the stop button to stop the web server at any time. So the next thing we want to use is the set the web server up, and we want to put in a starting file number for the socket threads. Now our array for the socket threads Now the next thing we want to do is we want to create a thread to monitor requests. There. Now this command will create a new thread using this function to monitor the threads. We have to pass it a variable, so we're just giving it a 0 if it's a dummy one. So we want to create this new function. So since this is a thread function, the name of the function is preceded by the word thread. Right, that's what this particular thread is going to do. So the first thing to do is to give the system half a second just to catch up with life. Now we want a couple of local variables in here to keep track of a thread number and the result of what's coming back. And we basically want a loop. Now this monitor thread will be running continually for the entire time the web server is running. And so it's not running constantly. Well, it will be running constantly, but so it doesn't do everything constantly, we want to give it a delay, a monitor delay. Now we set the monitor delay up right at the beginning with the constants, and we're basically waiting for 10,000 milliseconds. So basically every 10 seconds this thread will actually do something. Otherwise it'll just be sitting waiting. And we're going to do a for next loop. Going between thread number 20 and the maximum number of threads. And if we have a value in the array we're using to keep track of the threads, what we want to do is we want to check to see if this particular thread has already been marked as terminated, and then if it is, we close the dead thread. Basically wait a second and then use the thread close command to close it down. Now if for some reason the thread refuses to die off, we'll put a message out to the text window to say the thread close failed. Otherwise we mark both the thread handle number and the time as being 0. So that takes care of dead threads. And our next task is to work out if a thread has been running too long. And in this case, this section of code basically uses the timer. As you'll see from here, a timer function returns a number of seconds that will elapse since midnight. Now admittedly, there could be issues if you're actually running this over midnight, but we'll work on the assumption, keep this quite simple and not worry about starting a thread before midnight and ending after midnight. But if the time actually exceeds the value we've got in our max thread age, which in this case is 15 seconds. So if the time the thread has been running exceeds 15 seconds, then we mark it. And this completes our monitoring thread. Now that should compile, unless I've missed something. Yes. What have I missed? That's what we missed. The word function. Right, okay, let's compile that now. As a general rule, I try to compile every few minutes just to make sure I'm not going to have some great problem further down the line that is really difficult to work out. So, if we go back to our event handler, we've now created a thread whose job it is to monitor all the other threads. The next thing to do is to actually set up the listening part, where the program will actually listen for requests coming in. So, first thing to do is to pick up the network address of the computer we're currently on. That inbuilt function from PowerBasic, the host address one, should always return the network address, the IP address of the machine we happen to be running on. Now, for any reason it doesn't, then we're in trouble. But what we can do, having got the IP address, we can then push the IP address out to our text window, and I've created a new function called IP address, which will return the IP address in a readable format. And this is one we used in a previous program. So we'll just paste this one down here. This just takes in the IP address as basically a big number, and then treats it as a byte pointer, and then slices it up to return it in a reasonable format in 4 elements, as you would expect. Now, if we try running that now, what we should get is we should get our IP address being thrown out to our text window. So if we try running that now, there we go. It's put the primary IP address, network card is 192.168.0.16. Fantastic. So having picked up the IP address of the machine we happen to be running on, our next task is actually to listen. Now, you may wish to use this if you just want local host. So if you just want to use the standard 127.0.0.1 IP address, then basically pick up the IP address like this. Otherwise, doing it this way, it will get the actual network address of the machine. So depending on what you want, so for this particular demonstration I'm going to be using the IP address of the machine we're actually on. Now, we want to be open for listening, and we're using another TCP command which is inbuilt to PowerBasic, using the IP address we picked up earlier, and we want to put in the port number, which is a constant we created earlier, which we had set at 8000. And we'll want a file handle for that, which is another one we set up earlier. So what this is doing, it's opening up a channel by which you can listen to incoming TCP requests. And assuming this actually works, the error variable will have nothing in it. However, if it does have something in it, we can put a message out to the text window. I don't anticipate we'll have any problems opening a port, but you never know. Now, I'm almost done in this section. There's only one other thing to actually do. We want to set up a notification so that should something actually come into this port, we can pass the information on to the event handler. So we use another TCP command, TCP notify. Again, using the handle we just set up. And we're going to be passing to it the handle of our dialog. That's the one with the big button on it. And we need to give a constant for the event which we set up as one of our constants. Which we called page request. Now, one thing I just want to double check is when we set up the web server one, basically in the web server dialog, it creates a new dialog and it passes the value to here. Now what we want to do is we want to make that global so we can access it. So this is a global variable and this is a local variable. So when this dialog gets created, we're copying the value in it into the global one. So having done that, the code in here is now complete. So what happens is we open up a channel for listening. We then set up a notification to say that any connection coming into there is to be passed to the event handler that this pointer points to, using this as the event. So having this as the event, we need to go back into our event handler, and at the moment in the event handler we have the initialize dialog, we have the notifications, and we want to put ours in here. And this is the section into which our notification is going to arrive. And that some browser somewhere is asking for one of our requests. Now, how do we actually handle that? How do we accept the request? Well, we need a select statement. And in this case, there is already a setup too many P's, and we want the low word of that. And that will give us a value back, and the particular sub-event we're actually after is this one. So in here we actually have to handle, what do we do when our request comes in? Now we've got a thread sitting in the background waiting to monitor all these threads we're about to create. Now if the program was only going to take information in from one browser, we wouldn't need threads. We could just handle it one at a time. But web servers have to be able to handle things coming in from many different browsers and many different machines. So the ideal way of handling that is for each request coming in, you spawn off a thread, let the thread take the weight and do all the handling, and then you listen for the next thread, the next request coming in, and you launch another thread, and you just keep going. So what we'll do in this one is we want to pick up the socket based on the current file number, which is a global. We basically want to increment that so that the next time we come in, that's going to have a different value. And we want to check to see, have we got to the end of our file handles. So if that is greater than, let's see, so if it gets to basically 999, which is basically one less than the maximum number of threads, then we want to put it back to 20. I'm going to use another TCP command. And we're going to store the value inside that variable, hsocket. Now comes the point of actually creating the thread. So thread create, and we'll create a function whose job it is to handle all these socket threads, passing it the value, and we want to put this into our array to keep track of the thread handle numbers. And our array to do that was this one, and we'll be using that as our element of the array. And then we want to store the time that we started running this thread, which is our other array, which was a double. And again, the element's the same one. And again, we're using a timer. So, what we've done here is a request has come in on the TCP channel from a web browser requesting something. We've basically picked up the socket number based on the last number we handled, which starts us off as 20. We then increment this so that the next time it will be 21. If the number we've incremented here is actually greater than the maximum of the threads, then we put it back to 20 again. We do a TCP accept, picking up the socket number. We then create our new, or not create, but actually call our function, spawn our function off to actually do a thread to handle this request, passing it these details. We then record the time that that thread started, and then we go back to wait for the next request coming in. So we need to create a new thread. So down here, we have a new thread. Now this thread is the one that does basically all the work. So this runs a completely independent thread for each request. So to speed things up, there's a whole pile of variables we'll have to create for this to keep track of everything. So I'll just paste them in and we'll cover them as we get through them. And the first thing to do is to pick up a file handle. The free file command is infinitely useful to give you a number that has not been used already. And again, there's another loop in here. And this is our timer array. Let's just call that hsocket, make it a bit simpler. And then we'll have it as a loop. Right, let's just compile to make sure we've made no errors up to this point. And yes, we have. This has to be by val. You can't pass them by reference, you have to pass them by value. Again, so we don't eat all of the CPU up, let's give it a tenth of a second to actually think about things. And now we want to receive our data. We're going to receive it into this variable we created up here, the string receive data. And yet again, it's another TCP command using our hsocket variable. Now, if we have a look inside the help file, just to explain what we're actually doing here. It's like reading information from a file. Basically, you have a file handle number, which we've given it here, which is basically the file handle there. And the next one is the count. And that's the number of bytes you're going to be receiving at any one time. Now, we set it to be 1024 because generally that's a reasonable number. You can always increase the number if you're actually going to get really, really long transactions from a browser. But for the purposes of this simple web server, 1024 is more than enough. The buffer is the string into which you're putting the data. Now, if you're actually saying I want 1024 and the thing's only 100 characters wide, then it will still take 100 characters. It won't give any error. Having received the data that's come into this variable, we now actually have to process it. Now, before we do anything else, we'll want to actually populate our timer to say that this particular request has now started. So, just so we can give some feedback for this one, we're going to print a message out to our text window just to say that we've received a request. Now, since the information is actually stored within here, it will have characters and line feeds in, so it may be a multi-line request, but it's treated as one big long line. So what we're going to do, we're going to chop this line up so we can actually see in our text window what's actually been asked for. This isn't functionally needed in the web server, this is just useful for us to see what's going on. If you ever need to make one of these live, then this section can be completely cut out. So to do that, we're going to do a little for next loop, and this for next loop is going to first of all count how many characters and line feeds exist within this. In other words, how many lines of data have we got in here, and then for each line of data, based on the delimiter of the character and line feed, it's going to chuck out to this text window the line of data so you can see what it's doing. Now again, this is just for our sanity and actually knowing that the program is actually functional. So what we need to do next is a little bit of chopping up. So what we're going to do is we're going to use the replace command, which is very powerful, to replace all the carriage return line feeds and turn them into just carriage returns. And then we're going to populate our in buffer. And then we're going to do another loop. So basically, while this has still got information in it to process, first of all we want a very short release of CPU time, and then we want to specifically look at the data we've been given, and we're going to slice our data up into command and input buffer. The command in this case is two types of command that in theory we should be interested in. One is a get and one is a post. Now for simplicity here, I'm only going to be handling gets. Posts could be where someone's actually someone's filling in a form on a web page, and that's a bit more complicated to deal with, but all we're looking at in this particular program is the getting of web pages and the returning of files. So we'll leave the posts for a later video. So what I'm going to do here is there's a fair bit of fiddly code here, so I'm just going to paste all of this in and explain what the code's actually doing. So we're setting a response flag as we come in here. You'll see what that does in a moment. We're picking up basically the name of the file being requested, and we're then chopping that up, and then if we decide at the end here that there is actually no file being requested, then it's probable in this case that the user has just keyed in the name of the server but not the file, in which case we're going to be giving them back an index HTML. Basically they've given us no file to return, so we'll give them back the index, the standard one. Now this isn't particularly good at error handling, in fact there is no error handling, but it's good enough for what we're doing. Now we want to check to see if the file they're looking for actually exists on a web server. Now there are a number of ways of actually doing this. The easiest way is probably this. So if it's what they've asked for is not a file, then we're going to be giving them back. We'll give them back the index one. So we need to test of that. In theory the index file should already exist, but on the assumption that somebody's actually wiped it, if the file equals index, so we will create a function whose job it is to create this file, and if the file doesn't exist at all, we will create an error file. And if the error file doesn't exist, so we've created new two functions here we need to create, a write index page and a write error page. So we'll whip them in right now. These are very basic, straightforward functions. Sole task in life is to populate this variable with the minimalistic amount of HTML. Basically the tags to say beginning and end of HTML, the head to say what the title is, and the body to say what we're actually going to put onto the screen. And then we're basically going to write that out as a file to the location that the program actually sits in. And with the error page, we're going to do exactly the same thing. There we go. The classic error 404. So we go back to here. So we get to this point, then the file has been found. So a quick compile to make sure. 454 in function. Oh yeah, we've misspelled function. Right, so far so good. Okay, so we got to this point in code, the file has been found, and we'll be wanting to deliver that to the user. So this is where we come into the part where we're passing information back that the browser can actually understand. Now there is an international standard for the way this is actually handled. So what we do in this case, so we want to create first a content header. And the first thing we do is we work out what the extension of the file is. Is it an HTML extension? Is it an image? Is it a GIF? Or is it something else? So all this does is it sets a value into the variable content header to say what it is they're actually asking for. And having established that, so what we did previously further up is that we built up information here to work out what we're doing a get. Now further down after this section, what we'll want to do in here is read the information that's on the web server and prepare to pass it back to the browser. So we just want to make sure we're definitely finished handling everything to do with the headers. Make sure the get command's out of the way. And this is where we're testing our response flag, which we set earlier. And in here, we want to open the file. Now we're using binary in this case, in that we don't really know what format the file is in. So we just basically open it as one great blob, and we're going to send it off. So we're going to use the get command on the file handle for the length of long file, however long the file actually is, and we're going to pass it into the string HTML variable. And we're going to close the file. So all this does is it opens the file for binary reading and gets the file as one big blob and sticks it into that variable. Job done. Now one thing we could put into our program is we could do some fancy tag replacement, which we'll come up to later if there's time. Now to send information back to the browser, we need to set up the HTTP header, and this section here is going to do that job. It sets the type of information, the content, and the content length based on the length of however big the file actually is. and passing this information back to the browser. And at this point we want to update our activity timer. So basically we've got to the point of finishing off what we're doing, and there has to be another TCP print command to send the information back to the browser. Back to the H socket again, and we give it two pieces of information, the header, and we add on the string, which is the file itself, without a line at the end. So no carriage return line feed at the end of the TCP print statement. Now, having done that, we'll want to print something out to our console, just to let anybody who happens to be watching the web server know that it has actually done its job. So we're going to do a text print again. Just to say the file has been sent. And we'll put in the name of the file too as well. Now if we get that far, this particular thread has actually done its job. So we want to close off the socket that we've been using. So another TCP command. Assuming we can spell TCP. And we want to actually mark our timer to say that we have effectively done our job and that we are self-terminating. At that point, we can exit the loop and come out of the function. Right, there's a missing bit of logic in here, which should be this. This handles the traditional change between slashes and backslashes. Having received the information from the browser and put it into the string received data, we need to test to make sure that it's actually not 0 in string. So there has to be an if. Data. And then everything from here down needs to be indented down to the exit function. Right, okay. After the exit function, we have an end if and a loop, and another end if and a loop, and we close. Right, I think we sorted all the syntactic errors out. It's quite a long function, this one, and long functions can be difficult to actually work out what's going on when you've got many nested if commands. So, having done that, we've now completed the socket thread, whose job it is to sit, wait, and listen for things to do. Having given a task, the thread will first of all check to see that it's got something to actually do. If it has got something to do, it will update its timer. It will put information out to the text window. It will then add the information to a buffer. It will then check to see if it's a get command, which is the only one we're actually going to be processing. It will then look to see if the file exists, having changed all these slashes to the other kind of slash. If we don't find the file, then we will create an index file if it doesn't already exist. And if the file the user is looking for doesn't exist, we will basically create the error 404 file if it doesn't exist. And then having said that, we then check to see what kind of file it is that we're looking for, set the content header. We will then open the file for binary reading as one big blob, put it into an HTML variable. We will then set the headers up. We'll then return the value to the browser using the socket with the header and the string put together. We will then put a message out to the text window to say that we've actually sent the file, and we'll quit, marking the thread as being terminated. Right, okay, having done all of that, what we want to do now is try running it. I think we have everything in place. So if we run that program now, what it should do, yep, I expected this, since we're actually listening on a port, the Windows firewall of course naturally kicks in. It asks if you're sure you want to do this, in which case yes, we're quite sure. It will only do this once. Having set that up, we now have the web server running. So let's just move it over a wee bit so we can actually see what's on the screen. Right, so at the moment it's sitting, waiting and listening. So if we open a browser up, and we'll bring it in slightly, and we're going to be looking for is Octo, and we're looking in port 8000. So we try running that now. Hee-haw happens. So the problem we have is that what's going into the browser is not arriving at our web server. I think I've traced where the problem's coming from. If we look at the dialog we have that actually shows the web server form, in this we're using the dialog new command to create our dialog, and at the end of that command is a variable called HDLG, which is a D word, which is used to store the value of the handle of the dialog. Now, further down here, what we needed to do, this line of code here, where we put the value in that handle into our global variable where we can pick it up, this line of code was actually sitting down here and not before the dialog show command. Now, putting it after the dialog show command was causing us the problem, because the dialog show command is what shows the dialog on the screen. And the code would never get to this line until the dialog ends. So this global variable was never populated, and because it was never populated, the notify was going nowhere. So now that we've actually got that in the right place, we can try running our program again. So if we save that and run our program again, there we go, and we'll just convince the firewall that it's okay to run this. And we're there. Right, let's minimize that, move our web server over here, and there's our web server sitting waiting for information. Now, if we have a quick look at what I've created inside the folder that contains the executable for our web server. Now, there's an index.html page, which is the default page if you don't key a page. There's my index.htm file, which is the one we can specifically go to. There's an error.html, in case we ask for a page that doesn't exist at all. And inside our index, if we bring that up in the editing program, it's not a particularly big program. Basically, there's the start and end HTML tags, the body of the page, and two paragraphs, one saying this is a small web page, and one with a link to a second page. This will allow us to display information on the screen and give us a link to click on, which is a good test of our web browser. So if we open up our browser, And we'll make it small enough so we can see what we're doing. And what we will do in here now, if we just do that, you'll see inside here, as soon as we've done that, that the information has indeed been sent to the web browser. The web browser has received a request and it's sent back the default index HTML because we haven't specified the page we want, and the content of that is this. If we now go in and give it an actual page HTML file, and it has sent the file quite happily. If we click on the link, we'll see that it got the request in for the page and also for the new page and the file on the page. So there we have demonstrated that we have used the browser to send a request for a page to the website. The website has responded and also given us an additional image back. Now, while this is a fairly basic web server, it does actually prove the concept that you can request pages and get back the content of those pages with embedded images, and it will accept links. Thank you for watching.